Hey guys, so in our last video we talked about ionic versus covalent and just kind of like some properties of those, and now we're going to go into electronegativity difference because this calculation is one way that we can determine if something is going to be ionic, polar covalent, or nonpolar covalent. And so first I want to talk about this little table that we have here that I'm highlighting in green. Now, as a refresher, the arrow points, or the mouth of the arrow, so if it points like this, if it points like this, that means greater than. So that means whatever, I kind of think of it like an alligator mouth. So the mouth wants to eat what's biggest, okay? And so this triangle is the Greek symbol delta, and it means difference, okay, which in math means that we would need to subtract, right? So essentially it's our answer from subtracting our two electronegativities. And so if our difference is greater than or equal to 1.7, it's ionic, which means electrons are not shared, right? They're transferred, not shared at all. If it's less than 1.7 but greater than or equal to 0.4, it's polar covalent. And so this means the electrons are shared unequally. Okay, so it's kind of like if you have siblings and your mom tells you to share the computer, but your older sibling gets it for like 2 hours and you only get it for 20 minutes, right? Technically, y'all both got computer time, but it was not even at all. It was shared unequally. And if the difference is less than 0.4, then we would say it's non-polar covalent. Okay, another way of looking at this, which some people found a little easier, is if you make a line and you separate it into three sections. Okay, the first line is 0.4, the second one is 1.7. Those are two numbers. Okay, if it's less than 0.4, it's non-polar covalent. If it's in between 0.4 and 1.7, it's polar covalent. And if it's higher than 1.7 or equal to, then it is ionic. Okay, and so when we look at this, okay, we're going to be using this data table and these numbers here. These numbers represent the electronegativity values of things on the periodic table. Now, one thing you might notice is the noble gases have been left off, and that's because they do not have electronegativity values. They already have 8 valence electrons, so they do not want to gain or lose. So I guess you could say they're all 0. So first thing we're going to look at is this first one, H and H, hydrogen and hydrogen. So there's going to be a bond between those. And so we'd look down here, find hydrogen, right there. Okay, it has a value of 2.1. So I'm just going to kind of write that out beside it. 2.1, 2.1. Okay, now, which one is the more electronegative atom? Well, they're both the same, and so I'm just going to write hydrogen. Okay. Now, the electronegativity difference. You normally would start with the most electronegative atom, but since they're the same, it would just be 2.1 minus 2.1, which will give us 0. Now, this electronegativity difference, it's our triangle. So our answer is our triangle, or the delta. And so we look up at our chart, and I say, okay, where does 0 fall in? Well, 0 would be less than 0.4, so it would be non-polar covalent because 0 is less than 0.4. Now if we look at the second one, hydrogen and sulfur, well, we know that hydrogen is 2.1, and we know we can look down and see that sulfur over here is 2.5, and so that means the most electronegative one would be sulfur. And so we start with sulfur and say 2.5 minus 2.1 would give us 0.4. And because it is equal to 0.4, when we check our thing, If it's equal to 0.4, then it's going to be polar covalent. Polar covalent. Just as if our answer was 1.7, that would be ionic. If it's equal to it, it always goes to the one above. And so let's look at a third one, Na and Cl. Well, sodium is right here, 0.9, and chlorine is over here, 3.0. And so we have 0.9, 3.0. That would make the most electronegative atom, chlorine, and 3.0 minus 0.9 would give us 2.1, which would be, if we look at our chart, 2.1 is higher than 1.7, and so that would make it an ionic compound. And so you could keep going through those for all of them. Okay, another way is, one thing if you notice, if you remember on your periodic table, your staircase goes like this on your periodic table. Okay, and anything to the right of it is a nonmetal. Anything to the left is a metal. Okay, and so when we are looking at our values, okay, when we had sodium and chlorine, we had a metal and a nonmetal. So that is the definition of ionic. When we had hydrogen and sulfur, remember hydrogen is the exception. It actually is a nonmetal. So when I have two nonmetals, I expect it to be covalent. Now there are two types of covalent, polar or nonpolar, but you can use those positions to help you separate ionic versus the two covalents. And so that is one way to determine what we have. So you should keep practicing the rest of those.